I'm teaching a calculus class this summer. Yeah. Because we're going on a trip.
I feel like I write too much, like dead ass. Look, I feel like I write too much notes to like not know. I know. I actually. This is like probably the first math class I've actually learned something. But I'm like, man, there's just so much I need stuff to get stuck.
I know what you mean. I'm not a fan of, I don't know how you guys feel about it, when like teachers have pre-done notes that they give it to you.
I don't like it.
Because then you feel less connected to what the hell they're talking
I'm
about.
not gonna read it at all.
I don't like that. Of course, if I did notes that were like typed up, you would be, oh, I can actually read. That's amazing, Jeff. I can't, you write shit down there and I have no idea what you're writing. I'm sorry.
Better than how I write.
Oh, really?
Very much so.
I feel like for like special needs for you would have like, okay, this is a formula for this, and then this is what the symbol means, and this is what we do when you see this.
Oh, okay. Yeah, that's the part you have to know.
Like X bar, this deviation is this.
Yeah, this is the kind of flashcard kind of stuff you should make for yourself.
Yes.
So real quick, the distribution of grades. What stands out to you? Anything stand out to you about those grades? Huh?
Who said that?
Yeah.
Well, yeah, it's kind of like bimodal in all the weirdest ways, right? The two highest grades were, the two most grades were A's and F's. Also, the fact that, a majority of people, much greater than a majority, passed the thing. But the thing that stands out to me is the standard deviation, which is because of all those X's, right? So it's 22.3, that's huge. Okay. But yeah, so if you're somewhere in the distribution that you'd rather not be, and you can make corrections, it's best if you can identify why you might have ended up there. So if you didn't do the homework, that's an easy answer, right? If you did do the homework and you thought you completely understood everything and you still got an F, then come see me. We got to figure that out. Okay. So today is review day. So I've got the answer key for the practice test. I think the very first thing I want to do is create the formula sheet. So you can bring that with you next time, which is this Thursday.
Do you think I will understand calculus?
Well, I mean, stats is so different from calculus. I have not seen your algebraics much. All right, guys. So this test goes chapter 8 and chapter 9. By the way, before I forget, section 10.2, which is on the homework sheet. I'm going to make that extra credit. Let me write this down again. If you look at your homework sheet, do you see how there's a section? I'm pretty sure I made it 10.2 on your homework sheet. Yes? Do you see at the bottom of chapter 9 it says 10.2? Thank you. Okay. Let's make that extra credit. And just a quick word about 10.2. Does this look familiar at all? That formula? Yeah? Actually, it should be this. Yeah, okay. Real quick. All 10.2 does, it would have basically the same 5 steps. But what 10.2 is all about is we take 2 samples, not just 1. So, very quick. Apparently, I'm going to talk more about this than I thought I was. If I want to test a drug, don't I need at least 2 samples? Why? One of the samples will get. If I want to test the effectiveness of a drug, I should have 2 samples I take. One sample will get a placebo, and the other sample will get the actual drug. You guys with me? So, in a lot of cases, we're not going to just be taking 1 sample. You all understand that everything we did in chapter 9, we just took 1 sample, yes? We were comparing some claim about the population. 10.2 would say, our claim would be like, I think that the average time to relief for the new drug is gonna be less than that for the placebo. So you're comparing two samples. Are you guys kind of with me? Is anybody?
Yeah.
That's all right. So my Z-score formula, and again, this section is extra credit. I'm not gonna say much beyond what I'm about to say. Would have to have room for two samples, yes?
Yes.
So I'd have x bar 1 minus x bar 2 minus mu 1 minus mu 2 all over, all right, Jeff, you've gotten yourself into it now. Isn't that what sigma x bar is? You guys with me? That's what sigma x bar is. Is that cool? That formula looks very familiar, yes?
Yes.
Over here I'm going to have 2. 1 for each population, yes?
Yep.
So I'm saying more than I meant to, but that's okay. What's the square root of sigma squared? Sigma, right? Square root of sigma squared is sigma. So aren't these two expressions the same?
Yeah.
And so up here, I've got 2 samples from 2 different populations, and I'm going to have 2 different standard deviations. So that's as much as I'm going to say about section 10.2. I really hope you guys see every piece of our Z-score formula has doubled. Why? Because now we have 2 samples. Each sample comes from a different population. Right? The one that gets placebo would be the population of placebo getters, and the one that gets the drug will be the population of drug getters. I sound like some politician. Gotta get the drug getters. Alright, enough. So 10.2 is extra credit. You guys can do it or not. It's up to you. You with me? I'll almost definitely have an extra credit problem on the final exam, for example, that comes from 10.2. So if you do it, you have a better chance of getting that right. Yes? So again, 10.2 is extra credit. One reason it's extra credit is because that's as much as I'm going to talk about. You don't have to do 10.2 homework, right? If you want to try it, it's extra credit because you have to put more work in to understand it. Huh? As a bonus question, potentially. You understand? Yeah, I'm not going to test you in a section I talk that much about. Is that okay? Okay.
Tell me about this.
I could put whatever I want to in the bonus. I could ask you, hey, what kind of car do we run if I wanted to, which is completely nothing I've ever talked about with you guys. But if I wanted to, I could do that, right? It's a bonus. Who cares? You guys kind of with me? I'm not going to do that because I want to make it applicable. Okay. Is that cool? So it makes sense to me to have at least one bonus question come from a section that was extra credit. Okay. So if you actually do it, you have another way to get a little more credit. Okay. So let's do this. Let's make this formula sheet that we're going to need for this test. So it's chapter 8 and chapter 9. Chapter 8 has 3 main formulas. This guy here, his cousin, and then their friend over here. And something that people, not a lot of you guys did this, but some people always forget that square root, right? Man, I really have to apologize. I'm like really tired, so hopefully you can understand what I'm saying. Thumbs up. Okay. All right. These hopefully look very familiar. When will you use one of these 3? No. When will you use one of those 3 equations? If I ask you to make a confidence interval. When will you not use one of those equations? If I don't ask you to make a confidence interval. You guys with me? So if you catch yourself starting to do that and you don't see me say anything about confidence interval, stop, erase. You're doing the wrong thing. Are you guys with me? I always get somebody does that somewhere completely unrelated. Is everybody with me? Okay. So those are the 3 main confidence interval formulas, the ones that we've talked about. There are more, but again, we're in intro stats class. So
Then there's these kind of like on the side little formulas that I called feasibility formulas. Do we have enough resources to talk to enough people to have the error as small as we need it to be? So the main one comes off of this guy. So I'm going to put them right next to, I don't know why I write it like that. You can write it like this also. Either way, they're both the same thing, yes?
Oh, that would have been.
That's on the quiz, yeah.
Yeah.
I also put this one on the quiz.
Is that part B on one?
Hmm?
Is that?
Yes, the one that says how many.
That's what I couldn't.
So if I say how many people or how many dogs or how many snails or whatever, what letter does that relate to? What variable? No, what variable does how many? N. So obviously, okay, not obviously, John, but hopefully obviously now. If I say how many will you need? Okay, you know you need a formula N equals. Because that's going to answer the how many question. Does that make sense? I would never teach the idea like that in the first place, but now that you've gone through all the derivation, I can say, hey, there's a trigger. What's the trigger in the problem? It asks me how many? I want an N equals formula. Yes?
And then we got the last one that goes with this guy, the one that I forgot to put on the quiz. For some reason, Q got a big old hat there. I'm sorry.
Q just got a big old head, so. I could really Q. That's me. Everybody else got their quiz back, right?
So how would that one be asked for the percentage one?
How many people would you need to sample to be within 3% of the true percentage, blah, blah, blah.
Oh, so it's
Do you see how I have to say percentage? I have to tell you what I'm trying to be within. The true mean would be one of these two. True percentage, this one.
Cool.
Yeah, whoever's in the next room is like, let's go. Say again? Oh, she was basically asking what kind of question would lead me to use this formula. It would be how many things or people do you have to sample to be within such a percentage of the true percentage? How many? I need an N formula. Percentage, I need a formula with percentages in it. Yeah.
That was problem,
The one that I made extra credit, yeah.
yeah,
So if you weren't here when I said this, I made number 3 bonus because I forgot to put this formula on the quiz. I think like 4 people either remember this or reconstructed it, so I was gonna ask. But if you didn't remember it, so you're fine. I didn't make you remember it, you don't have to remember it. Okay. Alright, so that's chapter 8.
The new stuff in chapter 9, to be honest, there's not like a lot of new stuff in chapter 9. It's mostly just a repackaging of stuff we've done before. If you look at every step, most of them are old news. The new stuff was like the idea of hypotheses, getting the claim, which was a ho, which was a ha, the interpretation of the rejection region kind of stuff, but even that was based on stuff we've done before. Maybe. It's just everything at once is why it's a rough problem. And I think I told you guys there were like 8 steps when I learned it, but I made it 5 steps for you guys. Okay. You can make it 0 steps. No, legal. So from the only new stuff from chapter 9 would be like this guy, definitely. How many things in here are wearing a hat? 1. Good. So these 2 will come from the claim. Yes, the P hat comes from the sample. The P and Q will come from the claim. Because we always assume the claim is true, so that'll be our population percentage. Not the claim is true, but the number of the claim is true. Oh, because it specifically is the z-score I calculate in a hypothesis test. But you don't have to put the star. The star is my own little invention. If you don't want to put the star, you don't have to. And to me, if I'm a student, I kind of want that section to remind me, oh yeah, this is something I'm going to use in a hypothesis test. So the star is going, oh, that's part of the hypothesis test, right? If you want to, now again, you could bring all your formula sheets with you. But if you don't want to do that, you could put down here, this is old news. Yes? Yes?
Wait, we can, on this test or the final?
What do you mean? Sorry.
You say we can do.
Yeah, every test, you could bring all your formula sheets. I don't know why you'd want to, because then you're gonna confuse yourself if you've got all these probability formulas staring at you, but you're completely, you can just keep adding formulas. If I were you, I would make a separate formula sheet for every test, and then on the final, like you're saying, I'd bring all my formula sheets. Does that make sense? Okay. It's up to you though, I'm not gonna tell you how to do it, you can figure it out. And then one more I'll put down here just because this is kind of silly, but the t-score formula is exactly the same as the z-star formula. But it's just gonna have an S here, yes? But they really are the same. Our data minus the supposed middle divided by the spread. They're both, all of the z-score formulas are that, yes?
So the X bar on the bottom, that, you just ignore that.
Say
You
again?
don't put a number there, do you?
Oh, if you want to. No. Here, what is, sorry, this is getting a little messy, but what is sigma x bar? Sigma sub x bar, right? Not divided by, not any of that. It's just a type of standard deviation, yeah?
Yeah.
It's the old one divided by.
The square root of it.
So then what's S x bar? S divided by square root of it, yeah. So you can make that better on your formula sheet. I just jam it in there, sorry. I think that's all the formulas you're gonna need. If you come up with one that you think you should be able to have, let me know. There have been times in the past somebody brought something up and I'm like, oh yeah, put that down there. So don't feel like I'm gonna automatically shoot down whatever you come up with. The probability is that there's a chance I won't.
Should write a thesis paper on that star and publish it.
Oh, sure, yes.
So, that's just a type of standard deviation, we just ignore it, right? We just
What do you mean?
ignore the
Sorry.
X bar.
Oh, so again, little subscripts in mathematics just mean a specific type of this.
Yeah.
And the example I gave you was the slope formula. y2 minus y1. It's a little subscript, right? y2 minus y1 over x2 minus x1, does that sound familiar?
Yeah.
I'm sorry, I'm dredging up trauma. The subscript just meant a specific y, the y from the second one, the y from the first one. So subscripts just mean specific. What does H mean in these problems?
I would put it in the
Come on. You develop your claim, and then you put it in one of two hypotheses. HO, subscript O, is the null hypothesis. H subscript A is the alternate hypothesis. Subscripts are specific types of whatever the main letter is. So sigma sub x bar is a specific type of sigma. It's the one for groups of n. S sub x bar is the one for groups of n.
Got it, so if this one for T, right? Okay, I always forget, is X bar sample and M is population?
Mu, but I'll take it.
Yeah. So the S, that's obviously.
Sample.
Sample, yeah, because S, so you put what you're trying to,
We can do a problem like that.
yeah.
Yeah, let's do a problem like that. So again, what would tell me to use this if I was given, if I only had what? If I only had the sample standard deviation, I would use this, yes? And this is kind of reinforcing the same thing that this tells you. When do I use a z-score? Only if I know the population standard deviation. And obviously it's gotta be normal also, but you guys kind of with me?
Yeah.
So those are acting like notes, reminding you when to do those two things, because students are often confused about C and T. I wish you wouldn't be, but you are. And those formulas are showing you, hey, we made T because we only had S in this situation. That guy working at the Guinness Brewery, he had time in his hands, and we sort of trusted him, even though he was probably sampling this product. But it came out okay, we checked it, sober people. Yeah, I don't know. I'm sorry. I'm going off on a tangent, but so S goes with T, sigma goes with Z.
Right.
And that's the same T for the T-score chart.
Totally. Okay.
But it's also like Z.
All a T-score is a Z-score that's being made a little bigger. So T-scores
I know
are
that, but I'm
fundamentally Z-scores.
So
They just a little
the
bigger.
star thing is still tripping me out because it's
It's
like,
just because let's do a hypothesis test example. You guys want to?
it's like, what's.
If you didn't want to, I wouldn't
It's
understand.
different from a regular, it's not different from a regular Z-score, but you would use it in this.
In a hypothesis test, your rejection region is defined by a Z-score, yes, or a T-score, but you with me? So in a hypothesis test, I already have a Z-score before I calculate stuff in the sample. So personally, I just thought, let me differentiate those two, so it makes more sense. Is my hope. The Z is like our rejection Z. The Z star is from our sample, and then I can compare the two. Does it make sense? I wanted to make it clear because you have two Z scores running around in a problem. It's like, well, which is which? Z star is the one you made from your sample. Z is the one that defines where evidence starts in your picture.
Honestly, it's X bar, because like, they're all samples, so those are technically like, they're gonna be samples of bigger portions of stuff.
Sure.
And you just, like this Z-score.
All right, let's try this. Okay. So specifically, somebody just requested we do a T-score problem, like a hypothesis test that needs a T-score. Yeah. Okay. So let's see how creative, tired Jeff can be. Let's see. So let's say that. Okay. So now it's wide open. So I'm going to do this problem. We'll do it together, and then I'll open it wide up to whatever else you guys want to focus on. Yeah. We feel that the average stress level, this is okay, for stat students is higher than the national average. Does everybody understand that I'm completely making this up? But some of you guys might feel some truth to this statement. Okay. And I don't mean to add to your stress level, I'm sorry, but it's just, it just happens. So we feel that the average stress level for stat students is higher than the national average. Is everybody with me?
Yeah.
The national average stress level. All right, you ready for a completely made up thing? Is 4 units. I don't know. Screw it. Okay. We take a sample of how many stat students you want to take a sample of?
82.
82? That's insane. That's perfect, actually. 82 stat students and get a mean of 4.8 and a standard deviation of, oh, give me a second. Yeah, no, that's too much. That's screw it. Get a standard deviation of, just put something down, Jeff. There you go. Okay. Test the claim at a level of significance of 0.01. Okay, so everybody got what they want from that? So much more than I wanted.
Jesus Christ.
No CGs. So we feel that the average stress level is higher than the national average for stat students, so we take a sample. Now, real quick, was our sample mean higher than 4? Just to kind of check in with you guys with the concept. Didn't we get a mean higher than 4?
Why the shit are we doing anything else then? Why are we just going, done, next study, give me money, government?
No test.
Why? We got higher than 4, didn't we?
Cause
Because it's a sample, yes? And even if the real mean is 4, any sample I take could just randomly be different than 4. You with me? Alright, I really want this really understood, because often if I don't want to make a big deal out of this, students will just kind of go, oh, I'm done. Well, I'm not going to do any of this stuff because it's higher. What do you want from me? 4.8 came from a sample. So the real average could be 3. And we just happened to take a bunch of people that had higher stress. Right? Or maybe I stressed them out like, hey you, what? How stressed do you feel? Really? Okay. so I gotta kind of root out sampling issues, whatever. Not only do we have to have a sample greater than 4, it's got to be greater enough than 4. Yes? So that's why we set up what evidence is. So if the mean really is 4, a sample could be anywhere around 4. So I have to get past the noise. I have to get a sample that's so far above 4 that it is evidence that the real mean is more than 4 for stat students. Are you guys, does that make any sense? Shit. Well, I appreciate the honesty. Sorry, somebody was shaking their head vigorously. Okay,
Say it one more time.
real quick. There's an average age of gross blood students, correct? You with me? If we take a sample of 1,000 gross blood students, do you think that their average age will be the same as the whole population average age? No. So you know that any sample we take will almost definitely be different than the real population mean. You with me? So the fact that ours is different from 4 just happens to be in the right direction that we need does not mean that the mean isn't 4. We could have just our sample could have a mean of 4.8. Maybe the actual population has a mean lower than that. Does that make sense by itself? Okay. So I can't just stop if my sample immediately does by itself what I'm looking for. It's got to do that enough to beat the noise. Does that make any sense? If I take a sample of stat student, of any students, I could get a stress level of almost anything from the sample. To be evidence that the actual population mean is different for stat students, not only does it have to be more than 4, it's got to be so more than 4 that it accounts for all the possible variability. So when we do the rejection region, that's where we say that's how far away you got to get. Because before that could be just random sampling stuff. You got to get past that thing to show me evidence. That's the whole idea. Is that cool? Better. Okay. Or are you just saying that because you're like, well, it's got to keep on pushing. So, can somebody tell me? Oh, sorry.
just on the question, so on
Yeah.
the actual test, you'll have like we've had in like our in the practice, the test practice, you'll have like the questions, right?
Oh, hell yeah. I think I told you guys that. On the practice test, there was one problem on the back that I didn't have the 5 steps, and I figured just because the 5 steps were on the front page, who cares? On the test, every time I ask you a hypothesis question, I'll have A, B, C, D, E. You with me? Meaning you're not gonna have to remember what each step is. What is your claim? What are the hypotheses? Do you use Z or T? Right? I'm gonna do every single question. You don't have to memorize the steps. Is that cool? So at least you can do job. So, can somebody tell me in English what the claim is?
Mean.
Yes, higher meaning in Mathish? Greater than? 4. Kick ass. Higher than national. National is 4. Higher than 4. Mu greater than 4. What number will never show up in your claim or your hypotheses?
Oh, the mean.
The sample mean.
Oh, yeah.
Because before, in real life, I would have an hypothesis before I took the sample. So the sample mean, I wouldn't even have it when I'm writing my hypothesis down. Does it make sense? Why am I, you thought the average age of gross blood students was more than 30? how would you check that? You would go take a sample, right? Before you take a sample, you have to have an idea, a hypothesis to check. So we create the hypothesis before we take the sample. So 4.8 could never show up in our hypothesis statements because it's the sample mean. I haven't done that yet. Does it make sense? When does the sample stuff come into play? Step 4, step D, whatever you call it. When you do your Z star or your T star. So, does that make sense? Before you do a statistical analysis, you have to have a hypothesis to test. Yes?
For your stuff, so the HO is always where the equals gonna be.
Good. It's where the equals is. Does our claim have an equal sign?
No, so it'd be less than or equal to? Because
Well, let's put the claim where it goes first. Where's the claim go next to? It does not have an equal sign, so it can't go next to the hub. So it's gotta go next to the hub. So you put that in its right place, right? Then the one you left blank needs to get the opposite of what you just wrote. So what's the opposite of greater than 4? Less than or equal to, yeah. So real quick, if you wrote this, I understand why somebody might write this. How do you know right off the bat you're wrong? Because what you just tell me has got to be true about the hoe. Has an equal sign, yeah. Those are truly opposite. Since ha does not include 4, then null has to include 4. They're supposed to be opposites. So whatever one's missing, the other one's got. Yes?
So for complex with claim, when you're reading it in a sentence, is it always the first thing you see? That's what it's saying.
Oh, no. Not necessarily. I just happened to start this one off.
That's what you can do.
All right, listen. The claim, they won't always use the word claim, but when they do, you're like, thank you, bro. Yes? So they'll say stuff like, we believe, we feel, we think, it's believed to be, you with me? Those words are how somebody perceives reality. It's their own claim. So they don't have to use the word claim. I didn't use the word claim, I used the word feel. Where could I have put that first sentence? I could have put that first sentence somewhere else. But how do I know that's the claim being made? Because it captures what somebody thinks is true. Yes? Somebody is going to think something. So what word could they use? Feel, believe, think, claim, hypothesize even. Yes? Does that make sense? So that sentence could be anywhere. But it's the one that captures what somebody believes to be true. That's the claim. Is that okay? Yeah. All right. Sorry, you guys look oppressed. I contributed to that. Okay. Oh well, you signed up for it. Here we go. How many tail tests will this be?
1
In which side?
greater than. Oh,
Which means what?
right.
Good. So on part A, you don't have to draw the little picture. I just ask you, is it 1 tail or 2 tail? But I like to draw a little picture just to kind of double check myself. Yes?
So instead of point that to know if it's one tail, what the claim, right?
Do it again, sorry.
To know what side the tail is
Yes.
the claim?
The ha. This always sets up the rejection rings it's going to be. I can never show evidence for a statement that includes the quality. If our sample was exactly 4, our sample mean, is that evidence that the real mean is 4? Nope. Nuh-uh. I cannot show evidence for equal to. I can show evidence for different from. Yeah? If somebody's like, the average age of gross one students is 80. Just take a sample, we got, you're obviously wrong. That's the way it is. Yes?
How would it be 2 tail though? Because if you cannot have equal then in the hall, right? Or less than.
No, so it would be a 2 tail if the ha is not equal to. How do you not be equal to something? You're either bigger or smaller. 2 tail. I need this to make sense. Why is this 1 tail? Because where do I want my sample to show up?
I understand this one.
Okay,
I just
okay.
don't understand how it would be
But real quick,
two tails.
for this one, I need my sample to show up to the right, because that would show evidence that it actually is more than 4.
Right.
So if my ha was not equal to 4, what would show it wasn't equal to 4? Either it's more or less. 2 tails. Two
Oh,
directions
not
would show evidence, yes.
So if the hoe is just like,
Equal.
equal, then the other one is.
So the claim could be, we think it is 4. That would be the claim would go in for the whole. Or if somebody said, I think it's different from 4. Because then that's mu not equal to 4, that would go in for the whole.
Got it.
Those two would be 2 tail. So I told you guys, if you can't find a directional word, what's the directional word up here?
Greater.
Higher, yes. That's a directional word, yes? So it's going to be a one-tail test. If you can't see a directional word, very often it's kind of like I say, I think it's the same.
Or the same is equal to. I think it is this. That one's really hard because it's just the little tiny word is. I think it is 7. Okay, that's equal to 7. This would be a 2-tail test. I think it's different from. That's not directional. It's kind of like both directions. That's a 2-tail test. Yes, there you go. So when you have a specific directional word, less than, greater than, increased, gone down, gone up, more than it used to be. Those are all directional words. It's going to be a 1-tail test. One of those two.
This is why I'm a big fan of, I didn't do it down here, we just did it verbally. Find the claim in English. Because then you could focus on that by itself. Because look at all the words here. Look at them all. Right? And you could read about 30% of them. So that's pretty good. Because of my horrible writing. All right. So what's the next step? And again, I told you you didn't have to memorize it, but does anyone know what the next step is?
Z-score or T-score?
Yeah. Zort. Zort? Yes.
Sorry, I'm confused. So will the claim always be the same as the hop?
Nope, nope. In fact, we have specifically, I was very careful to do some examples where it wasn't. So if my claim had been, I think the mean is at least 4. What's at least mean? Greater than or equal to. That would go where? The hoe, because it's got an equal sign, correct? So the claim can be either one. Why was this one the hop? Because my claim did not have an equal sign. Good. So what in here tells me I can do something?
You have the.
Something tells me I can do something. In fact, you told me this, Natalie, I think.
Sigma or whatever.
No. That tells me which thing to use.
Right.
What tells me I can do something?
Greater than 30.
Yep. N is 82, greater than 30. So I know it's normal, which means I can do something. Now, which thing can I do?
T-score.
T-score, why?
Because you only have a sample standard deviation.
Because our standard deviation came from where? Sample. Good.
Do you guys, I desperately. Z goes with sigma, T goes with S. Don't just say, we know the standard deviation, so it's a Z squared. That doesn't make any sense. Which standard deviation do we know? Yeah, in this case sample, so I gotta use the T squared.
This is where I always get confused because, like, I know this, but, so, your standard deviation, you only have the S, you don't have the other one. And that's the mean. Okay, I get like this.
So real quick, how do I know the standard deviation is from the sample?
Because it's S.
It says it. We take a sample and get, okay, so that came from the sample, so it's S. I don't know sigma, I gotta use a T-square, yeah, yes.
But
So
if
if
it
you take
had,
a sample,
Huh?
so if you take a sample and it's not greater than 30, that's when you have to,
Hell no.
wait, what?
So I would never do this, but if I gave you a problem and I didn't say it was normal and the sample size was 17, what can you do?
Nothing.
Nothing. The official answer would be, I can't do this, Jeff, and you would leave it blank. I would never do that Because that feels weird for one thing, and for second, it would be like if somebody didn't notice it, you're wasting all this time doing a problem you shouldn't be doing. So I would never do that. If I give you a Haas's test and I want you to do it, I'm gonna make it so it works. You just have to figure out why it works. Yes. I could ask a question saying, what if I had this? Could I even do anything? You with me?
Yeah.
But I'm not gonna give you like a Haas's test. I'm like,
Oh, let's see who sees. They don't have to do it.
I'm not that evil.
Yeah.
Yeah. 10 years ago, I said check your loop in 10 years, and apparently, I'm still not quite that evil. I feel like a failure. All my math people, are like, come on, man, get evil. Well, some of my students don't agree. Somebody with me on that? So when you get to that point, it's really important to know which standard deviation doing it. If you cannot tell, assuming it's a sample standard deviation will get you through almost everything. If it was a population standard deviation, I'm gonna frickin' just directly say that shit. So you're like, I can't tell, this is a sample. If you cannot tell, it's a sample standard deviation, these T-scores. Yes? Okay. I'm sorry, Raheem, I keep. Huh? Oh, this is beautiful, because there's a homework problem about this. When do I have to use S? So if I did have the population and S, if I had sigma and S, which one would I use? Frickin' sigma, because what is S doing? It is trying to approximate what sigma is. S is our best guess for sigma. If I frickin' know sigma, I don't need S. So, real quick, if I tell you the population standard deviation is 7 and we go take a sample, can we calculate the sample standard deviation? If you have a sample, can't you calculate the sample standard deviation? Yes. Did we need to? Because we already had sigma, yes? I don't know if you guys are with me. So one problem in the homework specifically addresses this. If you have both, which one you use? You freaking use sigma because we only use S when I don't know sigma. Does this make sense? So if I gave you both, and again, this is a little bit tricky, so I would not do that to you on a test, but in the homework, I'm cool with it. If I gave you both, you're gonna freaking use the population. That's the certain one. I'm not gonna use an approximation for something I was given. Maybe. Okay, you're doing good. Everybody's awake. This is good. A little drowsy, but you're awake. Okay. Look at me talking. I can freaking keel over. So I gotta use the T-score. So now I do what? Rejection region. What do I tell you that helps? So we need a T-score that helps me. What else do I tell you that helps us? Yes. So alpha is 0.01.
Oh, no. Okay.
You're good. And what's that? He's the freedom.
And it was one.
Yeah, exactly. It would be 81, but we don't have an 81, so we're gonna go right down to 80. Yes, is that okay? It is 81. But I didn't give you a chart with 81 on it because I didn't want to give you the scroll. Yes?
There were a couple problems in the homework where you gave us protection updated.
Oh, yeah. I'm sorry, dude. If they don't tell you like a confidence level or an alpha, it's assumed to be 0.05. Because that, I think they do say that somewhere in the book, but I can't remember exactly where, but that's the most commonly used one. With me. So if they don't say, use 0.05. Yeah. You guys remember the first definition of unusual we used? Within 2 steps. Yeah, look at you shaking your head to get the right answer. Because within 2 steps, left 5% outside. So that is the standard idea of unusual is 0.05. So if they don't say, use 0.05.
If they don't say what?
If they don't tell you what alpha is in a problem. Yeah. Okay. Has anyone looked at that T-score yet?
2.639. Sorry.
And it's gonna go up here, yeah?
Yeah.
Everybody got 2.639? I love you guys. You're like, I'm not gonna look at it, they already did. All right. I crowdsourced that, so I'm gonna go with it. Okay. And then I can shade in my little rejection region. So just to reinforce what I said earlier, this guy thinks it's in here.
Because if the mean really is 4, I could get a sample kind of around 4. To show he's wrong, I must get a sample here. Because that's where he thinks it won't show up. If his guess is right. Yeah.
Isn't it one tail though?
Yeah, it's 1 tail, so it should be
2.5.
Oh, thank you. Okay, I crowdsourced it. I didn't look at it myself. So let me do that. I love you guys so much. Did you guys notice? I didn't even look at a chart. Okay, so let's all learn this together. 0.01, 1 tail.
2.37.
Yeah, 0.01, 1 tail. And I'm gonna stop at 80. 2.374. Thank you. That's why I checked in to make sure everybody got the same thing. Okay. That's my fault. I was just being lazy. I should have double checked it. So are you with me? So be really careful about the 1 tail or the 2 tail thing. How do I say this in words then? How do I get in here?
Greater than 2.37.
Greater than 2.374, then what can we do?
Jacob support, huh?
Because the hoe thinks it's in here. If we get out there, we can reject that guy, which means we would support the other guy. Yes? Yes. 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 There's only 2 things that could happen. You can reject a null or fail to reject a null. Now, some of you guys might notice I've written 2 things there, but I actually didn't. I wrote 1 thing. If I reject the one dude, I inherently support the other guy because the other guy thinks opposite, yes? So you can either reject a null because you got into the rejection region, or you can fail to reject the null because you didn't get there. Rejecting the null means you support the hop. Failing to reject the null means you fail to support the hop. Is that cool?
But in that, what would be do we have to always reject the null?
Hell yeah.
Okay.
Hell
So
to
we
the
never
yeah.
say fail to reject.
Well, if you wrote, if T star is less than or equal to this,
And we could write that and still get
yeah,
it, right?
yeah. I mean, technically that's correct.
Okay.
It's just not convention. But you're right, it's a good point. You could turn around and tell me when you're gonna fail. Yeah. So now that we set up where evidence starts, we're gonna go see if we've got enough evidence, right? So I set up how far our sample's gotta make it. So then the next step is how far did our sample make it? What's the information from the sample? What's the sample mean? 4.8. What was the sample standard deviation? 2. So what's the, how do I get the standard deviation for groups?
2 divided by square root of 82.
Kick ass. Which I would say is about 0.217. I could be wrong, but I'm pretty sure I'm close to right. Yes? Sorry? 2208? Okay.
Well,
Alright, I went a little too far down. I mean, come on. That's not bad for my head. In my head. 0.2, 1,
no, 2, 2, 1.
2, 2, 1?
Yes.
Okay. Sorry, go ahead.
Sorry.
What sort of sample we're doing that one? Because it says we need a sample for sample group.
S is the standard deviation of individuals. What are we working with? A group of 82, yeah? So I need the standard deviation for a group of 82. That's what this is. I'm not making my standard deviation into a sample one. That's what people sort of interpret that to be. I've been very careful with how I've not said that. So people are always like, well, why do I have to do that? It's already a sample standard. No, this is a spread for individuals. I need the one for groups. I don't care that it's a sample spread. It's still for individuals. I still need the one for groups of 82. That's what this does. That's why this doesn't care what kind of standard deviation it is in the first place. Okay. By the way, real quick, I just want to point this out. In Canvas, do you remember the little comic I have?
But the guy that comes up and says, "Oh, look at this! Holy shit, the stats!" And the other guy's like, "That's how I feel all the time." But it's, this stuff is amazing to me, but it's alright. So now, what do? I've got this spread for my data. I've got my sample mean. What do I want to calculate so I can compare it to the rejection region?
T-star.
T-star. Our data minus the supposed middle divided by the spread. 4511 is, I don't know, 3.63. I don't know. Huh?
I got 3.62.
Oh, man.
But I also kept it at 0.2208. I didn't
Okay.
write it.
So if anybody did 221, did you get 3.62?
Yeah.
Okay. I'm sorry. I'll retire. Yes.
The p-value stuff, I don't get that.
Oh, real quick. All right. There was a problem on the practice test. Number 3.
Yeah.
You can't find a p-value for the t-score.
Yeah.
I'll only ask you for z-score. That's my fault.
Yeah, I was so confused because I was like, this is a t-score.
I changed the problem from, like, I gave a population examination and then I changed it to a sample one, and I forgot to change that question.
Okay. But
That's-
how did
that's
you
mine.
find a
On the
p-value?
test, I'm not gonna ask you for a p-value. Let me see if you guys, I sense everybody's like, oh my god, please let the semester end. I get that. Let me say this. This t-score chart, in order for it to have as much information as the z-score chart does, it would have to have a z-score size chart for every row. So can you get a p-value for a z-score? Hell yeah, because we got a z-score chart. I can really get down into the nitty-gritty resolution. I can get the exact. This guy has nowhere near the resolution. It would have to have a front and back z-score size chart for every row, and you don't have that. You just have this thing. If that didn't make any sense, I'm never going to ask you to find a p-value for t-score because you don't have enough information.
Yeah, so what is a p-value?
Oh, what is a p-value?
Yeah, that's
Okay,
what-
okay.
Just hold on. Maybe we'll see. If we do another hypothesis test, well, okay. I'll make sure to address that, but I'll check in and see if anybody wants to do another one of these. If not, I'll just talk about that directly. What do I know from this?
That is, we just proved, or we proved our,
Yeah, we got way the hell out there.
yeah.
So did we find evidence? Did we succeed?
Yes.
Yes. So we can do what?
This,
Reject them.
Reject the hoe. Support the ha. That sounds like good life lessons. Sorry. I really hope I don't offend anybody. I just think it's funny. I could be very wrong. It could be horrible. I don't know.
Real quick, just to say this. If pretending like that was a z-score, I would get the area in the tail that 3.62 makes. That would be my p-value. Huh? There's two problems. That's not a z-score and it's also off our chart. But if you look up 3.62, and the tail it makes, yes?
The tail it makes. So if you look at 3.62, don't you get 0.9999? So what's in the tail that it makes that way? 0.0001.
and that's the p-value.
That's the p-value. And the fact that it is really tiny means that the probability that what we saw is just due to random variability is low.
It's,
The probability that's actual evidence against the null is high. So the smaller the p-value, the stronger the evidence against the null.
so that's just our.
What's up? Sorry? Sure. If you look up 3.62 in the chart, you'll get 0.9999. So the area in the tail it makes would be 0.0001. Because the tail it makes is up here, yes?
So 0.999 down here, so 0.0001 in there, yes? That's the p-value.
The p-value is roughly the probability that what we saw was just a random chance. So what's a higher probability that that actually is evidence that the mean should be moved up?
High. Wait, right?
This is evidence that the mean really, the whole thing should be moved over.
Yep.
The actual middle is higher than what we thought for that subgroup of people. So okay. P-value is effectively the probability that what we saw in our sample was just random chance. The smaller that is, the more likely then that it isn't, that it actually is evidence of something. So again, if the real average was 4, couldn't we just randomly get a sample of 5.3? Isn't that possible if I just if the real average age is 30, then I randomly get a sample of 40, of an average of 40? Of course I can, because randomly picking involves random variability, which means you could just randomly get a bunch of older people. Yes? Okay.
You didn't write the conclusion yet, right?
Not yet.
Okay.
This is still the study. So what's more likely if I get a really small probability that what we saw just happened by chance is that it is actually evidence that the real mean is higher.
Yeah.
I want this to make nothing but sense.
Right?
Watch this. If
Percentage is so low.
if there's 4, yes? And we get a sample here, which is what we did, yes? Doesn't that, one way to make that make sense, one way to make that make sense is if the damn picture was more like this. Wouldn't that make more sense then? What did I do? I made the mean go up, so that would be evidence that the mean actually is higher.
Yeah.
Because if I move the picture over, my sample makes more sense where it showed up. I love it. And some of you guys are like, you raised the volume of your voice, but you didn't make any more sense, Jeff. Damn it. Yes?
So the smaller it is, the more evidence.
The smaller the p-value, the more evidence that what they saw was not just random chance, it's actual evidence. Okay. And I'll show you, I can't remember if I showed you, did I show you all the little articles with the p-values in them?
Yes.
Okay. Yeah, like that didn't make sense either, John. Damn it. All right. So, what's my conclusion? What was my claim? Which one was the claim, the ho or the ha? Because it could be either one. Yeah, this was our claim. So the ha was the claim. So what language do I want to use?
We found evidence.
No. I mean, just these two.
Support.
Because it's talking about the claim, correct?
Yeah.
People are very often, they'll get the first 4 steps, you just kind of do the math and you get there and you're like, I have no, I'm just going to guess as to how to word this shit, Jeff. You got a 50-50 chance, right? Yeah, you do. But this is, which one's the claim? I need to talk about the claim, so I want to use the language that goes with the claim. In this problem, the claim was the ha. So I'm going to use this language. We have found sufficient evidence to do what?
Claim.
To support the claim that
The average stress level is higher than national.
the average stress level
For stat students.
for stat students is higher than the national. Okay, I crapped out there. Is Hig. Okay? Yes.
Sorry, I hate to go back, but I know that we found the p-values in the z-score chart, but in terms of this being t-score, like,
Oh, like I said, I was assuming that was a z-score just to make a point.
oh, okay, so it's not.
I would never ask you to do it for a t-score because your t-score chart does not have as much information as a z-score chart does, so you can't drill down that deep. If you don't understand anything I just said, I'm never going to ask you for a p-value with a t-score. So only give me the p-value when I ask you for it, and I know on the practice test I did, and I'm sorry, I forgot to take it out. Okay. Sure. Yes.
Really quick.
Yes.
So for 3E,
Did I remember to answer that? No. What would have changed? What's the only part of the problem that would have changed if we changed the alpha?
And this.
For what? Be very specific. There's only one thing that would change if I changed alpha.
The average.
What is alpha set up for us? Okay, so we're looking at this problem here. Yes?
Yeah.
Alright, so alpha was given to us as 0.05, correct?
Right.
What do we set up using that?
Rejection.
Rejection region, right? That's okay. So if I say at the end, how would anything have changed if it was this? This would have changed,
Your rejection rate would have been bigger.
which could potentially change the answer. So, like, if my rejection region was 2.17, yes, and my z star is 2.05, we failed, yes. If somebody had given me a different alpha that had a z rejection region of 1.96, we would have succeeded. So what this is trying to point out is alpha is kind of like determining does it succeed or not. 2.17 is pretty decently far away, yeah? It's more than 2 steps away, yes? If the alpha I'm working with says the rejection region is here, I didn't make it far enough, did I? So I officially would have failed, but somebody else could be like, no, I think it's good. They have a different alpha, they have a different level of evidence required. And real quick, isn't that true about everybody you know? Have you ever felt a certain way and somebody's like, no, I think you're wrong?
Yeah.
They have a different level of evidence required. For whatever, maybe for good reasons or bad reasons. You never know. You with me? Okay. Earth is flat. No, it isn't. Different level of evidence required, yes. Okay. Any flat earths out there? I'm sorry, I don't mean anything by it, just keep it yourself. I'll cry later if you tell me. Okay.
Doesn't make any sense.
Yes.
Can you write an example of it, like how you would respond to that question, just so I like will remember, you know?
Yeah, so real quick. Okay, let me see. I forgot to put this on the key. I don't know if you did number 3. Number 3 is going to be another T-score problem, right? Is it? Wait a minute. Damn it, Joe. Oh yeah, that's the one I already said I screwed up on. I didn't mean to put that, and didn't mean to put that, I'm sorry. It's going to be a T-score problem, yes? Okay. Can somebody help me out? If alpha is 0.05, and this is going to be a one-tail test, yes?
Right.
Less time, so it's going to be down here, actually. What I got was negative 2.021 for the rejection region, yes?
Okay.
Okay. And I think my T star was negative 2.62. Yeah, let me do this. I'm going to give you the answer key, and then it'll be a lot easier for us to talk about it. Because I don't want to have to redo the whole problem if we don't need to. It's already got it down here. But I did forget to do that second part of that problem, so we'll do that together. Okay, so. So looking at this problem here, let's double check past Jeff. Let's see. For this problem, I'm not going to redo the whole thing. It's a one-tail test. Alpha is 0.05. Degrees of freedom is 40, right? Because they don't have 41. So 0.05, 40 is 2.021. Good job, past Jeff. Okay. Is everybody with me? And the T star I got was negative 262, so I found evidence. If alpha was 0.005 instead, where would I get my T score from?
It would be
Which column?
the
Yeah, here.
Right.
Yeah?
Right.
And then my t-score for my rejection region would have been 2.704, yeah? You with me?
Yeah.
So this would have effectively become
You have to be more, like further.
2.7. Oh God, Jeff. I need more room. Here we go. This would have become negative 2.704 instead of negative 2.021. I really want you guys with me. Why was this negative 2.021? Because I said alpha 0.05. I would have not drawn it like this if alpha would have been 0.005. I would have drawn it like this, yeah? Negative 2.704, yes?
Yeah.
What was my T star?
2.62.
Negative 2.62. Would I have made it far enough away? Nope, I would have failed.
Yeah. So would it fail because it was further?
We would have failed because we didn't make it far enough. Our sample only made it to negative 262, and our rejection region required this. Now, it's kind of understood universally that 0.005 in most cases is too strict. But in some cases, it's valid. All right, the only point I'm trying to make there is I need you to really get this. I think I told you guys this. In the real world, not a damn soul is going to give you a freaking alpha if you're looking at a stats thing. It's not going to tell. They might tell you what they consider to be proved, but they're always going to report the p-value, because then I have my own standard of evidence that I can see. So somebody's like, they got p.02, that's not good enough, and I'm like, what are you talking about? 0.02 is great. You guys kind of and that's the way it should be. That's the way it should be. Is that they just report what they found, and then I determine if what they found was good enough evidence or not good enough evidence, yes? Now, unfortunately, a lot of people don't have well-founded ideas of what enough evidence is. Yes, like we talked about earlier. You guys are all with me? So whatever field you go into, if you go into nursing, and you look at an article about a nursing analysis, statistical analysis of something, you're gonna have developed over time a level of evidence for different things related to your field. Does that make sense? If you're a geologist, you're gonna have a level of evidence for things related to your field. So blah, 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 blah. You with me? And so when you look at an article, they give you a p-value, you can base it on your own well-established experiences and so forth to determine if that's enough evidence or not. Since we're not professionals in a field yet, you guys get an alpha given to you.
Got it.
Is that okay? So this is just me saying, what if in reality you were this kind of person or that kind of person? What if you were a 0.05 is good enough, or I need 0.005? Well, the 0.005 person would have not rejected the null,
Right.
whereas the 0.05 person would have. Yes?
Yeah.
Do you guys at all? Yes? Maybe? No?
Yeah.
Meet you more every day, Jeff?
Never.
Let me see. Yes.
Why is t-value negative 2.5? Are we using the area, the alpha level, like 0.5, the area in the two field or the area in the one field?
This one was a, oh man. So this was a one-tail test. Good job, Pass Jeff. So it should be here, yes?
Yeah.
Okay, thank you. And then if I go to 40, it should be 1684. Okay. So everybody make that 1684 there for part C. So I own my mistakes. So that was very much a mistake. I'm still averaging about a 97 on my answer keys, but
Wait, where is
3C, that 2021 came from two tails, but it's supposed to be a one tail test. So Emily's keep me honest. I appreciate that. I'm not making excuses, but I did this very quickly this morning, so I understand why I made a mistake. But just be careful about which number of tails you're looking at.
You had it easy on yourself, got a bunch of classes, lots of papers.
True, but I'm holding you guys to a standard, so I understand when a teacher makes a mistake, it's kind of like, hey, how can you take points off for me? But just notice why I made the mistake and don't make.
Really stats class, because the probability of how many different classes you have, how many different students you have, different tests and different things.
Yeah.
Not to mention unknown variables that happen in your life that may kind of distract them.
True. But I'll give myself, I'll take some points off. So.
Big measure.
Yes.
I wish there was a macro stats class on that.
Do you guys wanna do a specific kind of problem, or do you wanna, yes?
Just to confirm, on the back side, 6 is the 10.
No.
Oh, it's
Because it's not a hypothesis test. I just want you to make intervals for each.
not. Oh.
Yeah. Is that cool? So I like number 6. I don't know if you guys have done this yet. But if I get a confidence interval from like 2 to 6 for one group of people, and another group of people it's from 8 to 10, is that evidence that their means are different? 2 to 6, 8 to 10. Why is it evidence that their means are different? Because their intervals don't. They don't overlap. Yeah. So the one is basically saying we're such and so confident that the mean is caught between 2 and 6. And these guys are saying, well, we think this other group's mean is caught between 8 and 10. That is evidence that the population means are different. So if the intervals do overlap, that won't be evidence they're different because it's possible they're the same. So if one was 2 to 6 and the other one's 5 to 8, couldn't both means be between 5 and 6? So is it evidence that the means are different? No. Does it make sense? If my two intervals overlap, that is not evidence they're different. It's actually evidence that they could be the same. If they don't overlap, that is evidence that the population means are different. Is it proof? Never.
Is it going back to chapter 5?
Huh?
Is it going back to chapter 5?
For this problem? Oh, you mean for the test?
No.
I don't know.
You know what I mean? We're chapter that we did, it was that we actually, that we picked samples, and then they overlap.
Oh. Yeah, we talked about like back in chapter 2. You guys had to make a table and do x minus x bar squared and sum it up. Yeah, screw that shit. Just put it into the calculator and do 1 bar stats, right? You with me? So if I give you a set of data and you need the sample mean and the sample set, just use 1 bar stats, yes? Do you guys remember how to use 1 bar stats? Yes. Okay, good. Because you know I'm going to give you a problem like this. You know. So you thanks, Jeff. Yes.
4, I don't remember. Did you talk about hypothesis? I don't remember.
Oh, okay, good. Finally. Okay, I'm sorry. Because I keep forgetting to go back to it. I'm waiting for somebody to ask me. So let's talk about the types of error that could happen. Can somebody remind me the 2 things? There's only 2 things that can happen in a hypothesis test. There's 2 possible outcomes. What are they? Like get it right or get it wrong? Be quiet. Go ahead. Those are the 2 the 2 hypotheses. What could the outcome be? We can either succeed, which means we do what with the null? Reject it, yes? So 2 possible outcomes are, we reject the null, and what's the other possible outcome? Now real quick, before you say anything, reject the null means support the hop. So when I write reject the null, I said 2 things. I also support the hop, that's what that implies, yes? So don't say shit about the hop. I can either reject the null, or I can fail to reject the null. Why do we never accept the null? Because it can never show evidence for a statement that has an equality. A sample can't show evidence for that. So I reject the null, or I fail to reject the null. Can you tell me very simply if I do this one, when I would be wrong? When is it wrong to reject the null hypothesis? Huh? No. You almost there. when none of the ha is correct, when is it wrong to reject the null? If the null is actually true. You with me? Would it be wrong to reject something that is right? Is everybody with me? Okay. It's nothing more than that. That's a type 1 error. Type 1 error has got less words. I reject a true null. So what's the other thing that could happen? When is it wrong to fail to reject? When is it wrong to not be able to say somebody is wrong? If they are actually, if I fail to say the null is wrong, when am I incorrect? If the null actually is no. If I fail to say the null is wrong. So if the null is wrong, what do I hope to find out? I hope to see that it looks like the null is wrong. If I fail to reject a null that is wrong, I have made a mistake, correct? If somebody makes an incorrect statement and I fail to point out to them that they're wrong, I have made a mistake. Especially if I'm supposed to be a fact checker. So one mistake is reject a true. Do you all see how that is a mistake? The other mistake is fail to reject a false null. Do you guys see how there's a lot more words in the type 2? It's kind of the way I remember which is which. I'm going to give you a less mathematical example of this. If you're, all right, I always like this example, and I hope it doesn't tie into anything, but if you're a battlefield medic, you go up, you're with me? Or if you like to think about Game of Thrones, you're the cleric, and you have the healing spells, and you go out to the field. Let's go up like that, right? You're playing Dungeons and Dragons. You're the cleric. There's a big battle going on. You gotta go out in the field, and you have to help your friends, yes? When you get to somebody who's laying on the ground, what do you want to check before you try to start to
triage.
yeah, to see what? So let's go back to the battlefield, because the Dungeons and Dragons is a little too, because you can,
Yeah,
you
it sounds like-
can have a diamond, you can bring it back from the dead. Screw that
Yeah.
shit. You're on the battlefield, you come to somebody that's laying down.
Yeah.
You got a lot of people laying down, yes? What do you not want to do? You don't want to waste time on somebody. Now again, this is a little, this is very real life. You don't want to waste time with somebody who's dead. You with me?
Yes. We're gonna die.
You gotta get to the people that are still clinging to life so you can make sure they continue to do so. Are you with me? Because you're in this situation. So what do you do when you get up to somebody?
Triage.
Check to see if they're alive. So what is our
Are you okay?
what is our null hypothesis then? What am I looking for evidence of? Life. So my null hypothesis is they are dead. So I'm trying to find evidence that they are alive, yes? Do you all agree those are two separate, opposite statements? Is everybody with me? I'm trying to find evidence for the ha, which is what we always do. And I'm trying to reject what the null says, yes? If I think that, so what would a type 1 error be? Type 1 error is reject a true. So the null is true. So what is true? What is true? No. Type 1 error is I reject a true null. The null is true then in a type 1 error. What is true? No. What is true? Hear what we say. Type 1 error, I reject a true null. What is true then? They are dead. Okay, you with me? So type 1 error, they are dead. But we think what? Now hit me with what we think. We think they are,
Not dead.
I like it, not dead, just to be really careful. Okay. So in that case, what could happen because I've made a mistake? I could waste time with somebody that I'm not going to bring back. And somebody else could be slipping away. Are you with me? I do apologize for a slightly morbid situation, but I want the stakes to be a little high so you can see the differences between the mistakes. Yes? Yeah.
So if they are dead, the other person sitting over there is like, please don't waste time. Okay, what about type 2? What is the reality in a type 2? I failed to reject a false null. So in a type 2 error, what is true? They are alive, but we think they are dead. Now that is bad also, yes? You with me? Because I'm alive and you think of that, so you move on to the next person. That's bad. So there are consequences for both types of error. So in any given situation, if you can figure out, now real quick, you don't have to remember this, what I'm about to say, but let's see if it makes sense. The probability that I make a type 1 error is alpha. Alpha is the probability that I make a type 1 error. Because if I make alpha 0.05, for example, that means there's a 5% chance a sample would show up there even if the null statement is correct. So there's a 5% chance I get there and I reject the null, but the null was actually true. Are you guys at all with me? So if the type 1 error is really, really bad to make, I'm going to make alpha small. Are you with me? Now, the error, the type 2 error probability is a lot harder to calculate, but effectively, if alpha goes down, it goes up, but not perfectly together. Are you with me? So if I make alpha smaller, I am going to make the type 2 error probability a little higher. So I really have to be sure which one is worse. Okay. Which is why in real life, everybody sort of has their own alphas in their own fields, because they have their own interpretation of what kind of mistake is worse, more bad. Yeah, sure. Any grammar. Okay. Is that okay? So type 1 error is the null is right, but we think it's wrong.
Right.
Type 2 is the null is wrong, but we think it's wrong. If you want to state everything I just said in like everyday English instead of math teacher speak. By the way, I understand hypothesis tests, their individual parts are not that bad. It's just the fact that there's 5 parts. Yes. I think that gets people down. You kind of get them blending together a little bit. You really want to focus on each part one at a time to keep them distinct. Yes. Let me know if you have this. Yeah, type 1 is when the null is actually right, but we think it's wrong. Yeah. The null is wrong, but we think it's right. That's the kind of like quick way to say that. And in the real world, very often, we will never find out what's right, what's wrong. Yes? Which is why the joke back in the day was, one week it's okay to eat eggs, and the next week it isn't. Because we keep finding these studies that are sort of like counteracting other ones or showing different things, right? Which is why people don't believe in science, which is a horrible statement I have to make in this day and age, but because they somehow think science is like knowing what's true, period. No, science is like, this is what we really think based on what we see. We might see something else next week. And then people sort of like, well, then I'm not going to listen to you, then you're a bunch of bullshit. I'm like, holy shit. Holy shit. We would still be in caves, all this kind of shit, right? So science does the best it can do. That's why I love stats. Stats is like the science of math, because it is the math that says, we're never going to know 100%. We're never going to know 100%. You got algebra, it's 7, I know. You know, and stats is like, you ever take 3? So it's more real life stuff. And just I'm sorry, I won't go into a big rant about the disbelief in science nowadays, but it's like we're slipping back into a dark ages in this country, and that's the most stuff. So,
So, one thing I'm more, statisticians nowadays are just going a little insane. If more students took stats and kind of took some stuff out of it, we'd be in a much better place in this country, because there's a lot of misunderstanding about a lot of situations, how to interpret science, if science is true, and now all action stuff. Anything else you guys want to focus on, so I don't rant about the state of the world? Now, obviously, whenever you have a review day, the minute you got your question in, you can head out. That's fine. Some of you guys are looking at me like, please say the magic phrase. Just leave, just go. That's fine. Normally the magic phrase is, next time we'll, and then people start packing up.
She has children's books. She
What's the name? Laura Cal?
I'm trying to give her changes. Her name's Laura. Always out and coming out and Barbie stuff. She gave me a whole bunch of stickers.
So she sings and she does? She also?
She wrote a book called The Crane. The Crane from Spain.
The what? The crane from Spain?
The Crane from Spain.
Yes.
Okay. I don't know, man. I'm just,
Why, Georgia? No.
yeah.
And so, it doesn't matter if they were active. Most of the team on the other team is not divided.
That would be.
I'm worried that.
That would be like 2 classes.
I don't want to do that.
Oh my god.
Yes. I wanted to make sure, because I pushed one class back. I think I left theirs to today.
Very good people screaming about you, but I already got it.
I mean,
I normally don't try to make it like.
They see it.
I know, and I
Is
feel
it
like,
harder to retake it?
I feel like it when I see
So I've ever been a part of
yeah.
nightclub, and next time, it's one of those places where I can't leave, it's like, y'all really fucking had it.
I just don't.
Well, I'd say.
Wanted to make it.
Hold off on it, because if you're still in the class, you're still going, which means you're going to study for the final, which means studying for this test will help you get ready for the final. So, you'll obviously have this test, right, so that's a really good reason. In fact, thinking back, I should have put it together that we should focus on this.
Yeah.
I was just thinking about this in next class, I didn't want it to be too long. So we'll focus on this test. We'll evaluate after this test. Because after this test, you can start to get ready for the final, and then this test might help you focus on that material. So it's gonna be good to study for it, because
Also, I was missing a lot of days when we were learning that chapter, so there was some worksheets that I feel like
yeah. One thing I really love about it is putting stuff in Canvas. There's never think about it.
Yeah.
But if you send me an email, I can send you all the handouts, you just pick out the ones you get. Yeah. You guys, let me know if you have questions. I'm still here. But, by the way, guys, if we're having a meeting today, I'm not gonna be there.
We are,
I hadn't heard anything.
I found my grandma unresponsive yesterday, so.
No, what's up? Is she in the
In the
hospital?
hospital now,
Okay.
we're gonna go back out there.
Understood. Do they know what's going on? You don't have to tell me
They're
anything.
trying to figure it out, they're not exactly sure if it's like anything, I think it's neurological, but.
Okay. Is she responsive? So is she still on response?
No, she's fine with responsive, but she's going up.
Oh, I see. Alright. Family and health always comes first, so hopefully everything turns out the best. Yes?
How does Adidas include work? Like, because we're not sure Monday with
Oh, okay, so here's something I definitely don't say too early in the semester. So, I can't remember if I said this already, but you know in the syllabus it says homework and quizzes are together at like 20% of your grade or something? Homework itself is 5% of your grade. So it's not gonna, affect your grade, and as much as you might think. Now, this doesn't apply to either one of you guys, but I also tell people that I don't let homework fail you, but neither one of you are in danger of that. So if you got something back from me and I said finish, that means you got half credit for that. So if you got 2 of those like that, that means you're kind of effectively missing one assignment, because half, yeah. And then it's up to you if you have time or not to finish it. But what I'm trying to tell you is,